All right, here we are again. Graphing rational functions. Remember, rational means fraction. So graphing fractions. Um, I know this is new, but I'm going to try and make it as easy for you as possible. You'll be relying on your calculator a lot until you get the hang of what it is that you're doing. Now, rational functions look like this. Here's the graph of f of x equals 1 over x. It's going to look like this, and then it will also look like this. Okay, and what is happening here is there are some boundaries. It looks like two different graphs because this graph cannot touch nor cross the y-axis, and it cannot touch nor cross the x-axis. These boundaries are called asymptotes. Asymptotes. A vertical asymptote is the line x equals some number, and that number will be whatever makes the denominator equal 0. Well, what would make this equal 0? Well, 0 will. So the vertical asymptote for this particular graph is x equals 0, which just happens to be the y-axis right here. Sorry, right here. Now the horizontal asymptote will be y equals 0 unless you have a y-intercept added or subtracted to the rational function. So the horizontal asymptote y equals 0, or the x-axis. Range, domain. Well, the range, well, let's start with the domain. The x's cannot equal 0 because our graph will never touch the y-axis, so x can never be 0. So our domain for this graph is going to be x's less than 0 and x's greater than 0. Likewise, the range, all the possible values for y. We're going to keep going up and up and up until we get here. Then we have a hole in the graph where y equals 0. Then they're going to start again, and they're going to keep going up. So our range is y's less than 0 and y's greater than 0. Not greater than or equal to, or less than or equal to, just less than and greater than. Now when we stick a negative sign in front of a rational function, here's what it makes it do. It makes it flip over the x-axis. So this now turns down this way, and this one flips up to here and turns this way. Okay. The asymptotes are exactly the same. They'll not cross x equals 0. They'll not cross y equals 0. The range and the domain are still absolutely the same. Okay, for peace of mind, let's just get to the calculator. Go to y equals, let's type in 1 over x. You can either do that as 1 divided by x, but if you type your fractions in that way, then get the habit of putting them in parentheses. Or you can push alpha y equals, enter, and now you can type it in as a fraction. And then push graph. Here we go. Now go back. let's change this to, well, negative 1 over x. And there you go. Okay, so what if they start getting more complex? What if it's something like, oh, I had one here. It's not easy working at home. I'm sure it's not easy for you either. All right, here's what's going to happen. We'll graph this all right, and it'll turn out okay. But look at the bottom, the denominator, x minus 5. What is going to make that equal 0? Well, if x was positive 5, it would equal 0. So that tells us that we're going to have an asymptote, 1, 2, 3, 4, 5, here at positive 5. Here's the line that my graph just absolutely will not cross. Now you notice at the end here, minus 2. This is a y-intercept. Okay, this is going to cause the entire graph to move down 2. And so there we will find another asymptote, this time the horizontal one. So negative 1, negative 2. These asymptotes coming together look like the coordinate system just scooted over this way and down a little bit, and indeed it was. So now we can draw our graph. And we're done. Well, almost done. Okay, so the vertical asymptote was x equals 5. The horizontal asymptote y equals negative 2. The domain is going to utilize these two numbers right here. Okay, it's going to be x's that are less than 5 and x's that are greater than 5. The range, y's that are less than negative 2 and y's that are greater than negative 2. Now you can make a table of values to do this with. You can type it in your calculator first and try to see where these asymptotes are going to be. I go to my calculator and I type in, well, let's see, alpha y equals 6 over x minus 5 minus 2, and I push graph. All right. So let me count here. 1, 2, 3, 4, 5. There's my vertical asymptote. And then negative 1, negative 2, ooh, negative 3. Could it be? No, it's negative 2. It's going to continue going out this way, only it will never ever touch or cross where y equals negative 2. Okay. I think that's all that you're going to need to be able to do this assignment. Once you get the hang of it and read through all the notes that I left you, I think you'll be able to do it without much problem at all. But if you get stuck, call me, message me, send me a picture of your work that you're having questions about. Just let me know. I'll be glad to help you. Have a good day. Bye.